there's me down in the corner there. So we are going to do a lab here, this fan cart lab. I think I got all the windows that I need. I'm going to show you how to get that document started. And I don't need that. Let's get rid of that. And here is the fan cart lab. Went into Pivot. I found this fan cart lab. And let's see what this says. Watch the video below. Turbine, which is like this little fan on the cart. Let me go back to the start of the video. This is a little fan here. So it's like a little jet engine on the top if you want. And let's see, you can change the mass of your cart, and you can change the setting that the fan is on. So we'll mess with those things in a minute. And you can, let me get rid of that. You can bring up some measurement tools here that we'll play with in a few minutes. So that's what that looks like. And you can read through before you start. If you haven't done so already, you should pause this video and go ahead and read through the instructions in Google Classroom. And I'll let you pause here, do that. Okay, so now that you've read through those, it's a lot of stuff that we need to do here. So let's get started and see what we need to do. The first thing that we need to do is figure out which cart we're supposed to use. So my last name starts with M. So the instructions say for me to use the 2,000 gram cart. After I select that, I need to click load. All right, so it's loaded up with a little bit more stuff there. And that's good. I am not going to change that for the rest of the lab. And I'm going to put right here at the start of my document, this is McGrath and cart. Let's put a title there. So the mass of my cart is, it says to do it in kilograms. So I will follow my teacher's directions. This is 2,000 grams. That is 2 kilograms. Conversion. Okay, so let's see. What do I need to do next? The next little bits of instructions here. It says that I need to make a first data table that includes the force of the fan above the table, time, position, and velocity with at least 7 rows. Okay, so let's see if I can do that. So how do I figure out the force of the fan in this case? So I'm going to go into my tools here, and I'm going to click on this. So a spring is a good way to measure force, and they've given us this little scale here. Right now, this looks like it's slack, so I'm going to line up 0. I'm just going to use the edge of the spring here, but it doesn't matter what you line it up to as long as you measure from the same place every time. So you could line it up to the edge of the spring. You could line it up to like this little thingy here, whatever you want. I'm going to use edge of spring. Okay, so go line it up there. And then I am going to see here, when they turn the fan on, okay, now the fan is on and pulling on the spring, but they haven't cut the ribbon yet. So this, like when the fan is turned on and the ribbon has not been cut yet, that is where we can measure the force. So I'm looking in here, and these are, let's see, that's 0.1, 0.2, 0.3. You can move, well, I don't want to move that. It's pretty close to 0.5, I think. I'm just going to call that 0.5. So just be careful with these, what the lines mean there. Okay, so for data set number 1, or let's call it this, fan speed 1, fan speed 1. The force is, we just measured that up in the video, it is 0.5 newtons. Okay, and then I need a data table. And I'm going to have 3 columns and 8 rows. So I can have 7 data points. There's that. It's going to be, let's see, time, not time in seconds, and position, meters, and velocity. And we have a new improved way of finding velocity. I'll show you in a minute. It's going to save us some time compared to the way we did it with like the ice puck on the ramp and those earlier labs. Okay, you might want to, since I'm going to have to do this for fan speed 1, 2, 3, 4, and 5, you could copy this whole table, Control C, and then make some more copies of it. That was 5. You could do that. It might save a little bit of time. Okay, so now that I've got that, I'm going to go back to my video and I'm going to bring up my measurement tool so I can get the velocity of this thing. I'm going to go ahead and line that up right with the edge of the cart there. Again, you can line it up with whatever you want as long as you're just always measuring from the same thing. And I'm going to need my timer. And I want to get this to the point where the ribbon is cut right there. Okay, so then I'm going to 0 my timer. And let's see, from there to the end, if I wanted like 7 times to go with that, it looks like I could do like every, let's see, I'm trying to think of a good increment to do the time by. Let's see, so that's where it gets cut. So I'm going to do 0 time here, and then I'll go up by maybe quarter seconds. I think that's good. And then I'll get 7 there. Okay, so I'm going to go up by quarters there. You can go up by whatever you want, just as long as you're consistent with it. And you wouldn't want to go like use the first 7 frames because it barely gets anywhere, barely starts moving. So go ahead and put those in. 5 and 1.5. Right? My position, well, it's 0 at time 0. And then at 0.25, I think that's what I've got here. It looks like it's at 1 centimeter. Now this, I want this to be in meters. So 1 centimeter is 0.01 meters. Very important that you do those conversions, right? All right, let me go ahead and go up to the next. You can also scrub from here, get back to 0.50. And that looks like it's at 1, 2, 3 centimeters, 0.03. And then get up to 3/4 of a second. Looks like I'm at 7. These are nice, right on those centimeters. Nice data. 0.07. And then I'm going to go up to a second. Oops, past it, there we go. Right on 12.12. And go up to 1 1/4 seconds. And it looks like that's close enough to 19, right? 0.19. And then 1.5 seconds. We've got 27. Okay. That looks good. You can do more than that. It's just that a 7 is the minimum that I would like you to have for each one of these. Okay, so what else do I need to do here? So now I need to go into graphical analysis and, oh, there it is, my window. And I'm going to do manual entry. You can do this in Logger Pro too, of course. It works just fine. And do manual entry here. This first column is going to be, don't leave them X and Y, because that just stinks. This is going to be time measured in seconds. And apply, and we're going 0, 0.25, 0.5. I guess here, if your last name starts with the same letters, M through P, is it something like that? And you're getting some free data here. Lucky you. But we're going to have to do this a few more times. So feel ripped off, please, if you have a name outside that range. And then my Y values here are going to be position, column options. And it's going to be position. And we've got the SI unit for length there. Meters, apply, and let's see what we got here. It was 0, and then 0.01, 0.03, 0.07, 0.12, and 0.19, and 0.27. I think that you can also copy in here if you want to. That does work. All right, and that looks like a nice bending curve upwards. That's what we would expect position time to look like for something that has constant acceleration. So that's good. Now, what about velocity? I need to add a column here. So I'm going to go to the 3 dots, add a manual column, and it's called velocity. And I think I have my other ones capitalized, so that's going to my OCD flare up there. I'll change it, and that's okay. And then how am I going to get those? I am going to go, this is our new better way of getting velocity data. I'm going to go in here, and I'm going to turn on this tangent, turn that on, and then I'm going to go back to my graph, and I'm going to hover over each one of these points. And it's going to tell me a slope there. I don't know why I didn't do it for the first one. Probably, because there's not a point on the other side. But I know that at the start here, the starting velocity of this, because it was just being held in place by that ribbon, the starting velocity here is, in fact, 0. And then for my first point here, this slope right here, it even has the right units, meters per second. This is my velocity. So that's 0.0811. Isn't this nice? So easy. And then here, this is 0.125. And then here, my slope is 0.18. And here, 0.235. And 0.235. And here, I've got a slope of 0.279. And I think it is not going to let me get one for the last point because I don't have another. Oh, it is. Cool. It is going to let me get one for that, 0.304. And that makes me think that I was clicking in the wrong place here. Will it let me do one for this? Yeah, it will. But that should be 0 anyway. So we know that that's 0. All right, or maybe it shouldn't be 0. This says it's I don't know why it doesn't want to show me there. Oh well, we'll just leave it at 0. Okay, so what do we do next? I want to, if you look back at the instructions, the next thing we're supposed to do is, these are my instructions, I know what they are, but it says make a graph of velocity versus time and an equation and a clear statement of the meaning of the slope. Okay, so I want to make a graph of velocity versus time. How do I do that? I just click on this and change it to velocity and turn position off. And there's my graph of velocity versus time. I don't really like that last point. The last point, like the way that this does the whole thing, Yeah, I'm gonna throw out that last point. Don't like it. See how like these ones are in a nice line, these 5, and then this one's kind of off, and this one's kind of off. So when I do my line of best fit, um, I'm not going to do that last one. And I would recommend for you, just don't do the slope for your very last point. Get the 5 in the middle here. That should be good. And then I think I'm going to ditch that also. That looks better, right? Okay, so I want this graph, and I want it to have title. This is velocity versus time and speed number 1. I'm going to have 5 of these eventually, so I'm just helping you with the first one here. I would like it to go, I always like this to be scaled from 0. So I'm just going to go ahead while I'm in here, make that 0, 0. And I got my line of best fit. It's already there, except for, oh, that's just a tangent line thing. So let's turn that off. And let's go into apply curve fit, linear, and there's my equation. And this is what I want a screen snip of. So I'm going to do, let's see if I can remember how to do this. There we go. Bell means I'm supposed to be eating lunch right now. This is more important. Okay, so there's my first graph. And that goes with this. So I'm going to stick that in, not at the end. I'm going to put it right here. Versus time number 1. And then I'm going to make my equation for that. So equation, and I will go ahead and insert an equation. That's what I'm doing. This equation should be velocity is equal to, the slope is 0.2, I'm going to say 0.20. Let's use the first 2 sig figs there. What would the units be for this slope? Well, units of slope are rise over run. So meters per second over seconds. So I'm going to make a little fraction. Where is that? Right here. In my equation. On the top, I'm going to have 0.20, 20, and 1, because I keep typing 1. There we go, 0.20 meters over seconds. And then the bottom of that, you can put 1 second, or you can just put seconds on it. And down there, slope times time. Out of my little equation thing. There we go. Times time plus the intercept is 0.03, let's say. Pretty close to 0, 0.03. And the units of the y-intercept are whatever the units are on the y-axis, meters per second. And here, I am particularly interested in meaning of the slope. Meaning of the slope for, remember we read slope from the bottom up, for every 1 second, every second that passes, the velocity increases by 0.20 And what is that? When we talk about the rate that velocity is changing at, that's the acceleration. This is the acceleration and so I can have it in one place here. Let's say this, just a note to myself. This was force. So let's see, what was my force here when the fan, it was half a Newton, so 0.5. Okay, so that's what you have to do. And then you got to do that again for the next setting of the fan. Back in pivot. So you're going to go in here and you're going to change, you're going to leave the mass alone. You're going to change to fan force 2. You're going to load that. and you're going to do it again. And this is all lined up. So I'm going to see how much force now. I'm going to repeat all the same steps. And it looks like we got like maybe at the edge of the spring that 1.05 newtons. The first, each one of these little lines is a 0.05. So I would do that here. So the force is 1.05 newtons now, and then I'm going to get my new position and time data, all that, make a new graph in Graphical Analysis or Logger Pro if you're using that. Do all the same stuff. Notice here I'm going to have to move it's stretched a little differently now, so I'm going to have to just move that over, line it up with the edge of the cart. Everything else is the same. You're going to get a new equation under your new graph, and it's going to have a new acceleration that goes with a new force. So after you've done all of that for all 5 fan settings, then you're going to make a new table. Insert a table. And this table is just going to be 2 by 6 because here it's going to have acceleration, which is measured in meters per seconds squared. And here it's going to have force. We only have 5, right? With the 5 different versions of this that we just did, that you just did. I only did 1. And then in each one of these rows, I'm going to go back. So my first one, what did I have? I had an acceleration that was 0.2 and the force was 0.5. So acceleration was 0.2 and the force was 5. So you're going to end up with 5 data points, 5 different accelerations that go with 5 forces. And then you're going to go back into graphical analysis and make one last graph where, let's see, how do we just make a brand new one of these? I guess data set 1. Add new data set. So there you go. You do that. And then column options, want to change the name of this. This is going to be acceleration. Of course, you know how to do this at this point. Too much for you. Maybe apply that, and this would be your force. And velocity, we don't need that. Is there like a delete? There we go, delete column. So bye-bye to that column. So this is my data set 2. If you kept all of yours and you kept making new data sets, I guess this would be your data set number 6 because you had the 5 above. So my first entry will be 0.2 and 0.5. And certainly you might think that, like, does it make sense to put 0, 0 in there? Well, if there's no force from the fan, there'd be no acceleration. You could try putting the 0.00 because that would make one more. You know how to fix a data table if you're like, oh man, I wanted one more column in there. Well, right click on it and do insert row below, and it makes another row. So when you type in your, or when you select from that insert menu here, when you do the table and you do this little thing, you're not really committing to that. Like, you can adjust it after you put it in. So no worries if you don't get it exactly right. All right. And then the last question is, so once you get the equation for this, force equals something times acceleration, like, what do you think that is? What does that number look like? And does it match up to any characteristics of your cart? Hint, hint. So there you go. That's a good bit of work to do, but it's not hard. It's just got to go through the process. Make sure you collect your data carefully because then you're going to get good data. Right? That makes sense. All right. Let me know if you have trouble.